Hello everyone, we're doing a little bit of revision. So I know we've been mainly focusing on inequalities and I've explained the difference between an inequality and an equation, but I just want to go back a step and do some revision. Let's talk about equations for a second, and in particular I want to talk about graphing linear equations. Now I know we haven't been really focused on the word linear, but I want to just remind you of what a linear equation is before we move on to actually linear inequalities. All right, so remember I said right at the beginning that a linear equation or a linear inequality has got something to do with a line. And I drew you a line x equals 17, I believe it was from memory. This is another set of lines that I've drawn for you. This pink line here is x equals 6. Okay, so here is a pink line where x always equals 6, and these blue crosses that I've put on this line, it doesn't matter what the coordinates are, it will always be x is 6. Now the value of y will change as it goes up and down on the y-axis, but you'll see that the x-axis, it's not changing, it's staying on number 6. I haven't written the numbers on, but if we counted 1, 2, 3, 4, 5, 6. Let me just zoom into that so you can see it a little clearer. Okay, so just once again, x equals 6 on this line here, because everywhere you go, no matter what set of coordinates I asked you to label, x would be equaling 6. Let's just do this point here, for example. All right, so we know that we write our coordinates in the format x, y. So x is 6 because we would count out 1, 2, 3, 4, 5, 6. And the y value we would be counting down 1, 2, 3, negative 4. Okay, but it wouldn't matter which one of these points we plotted, the x value would always be 6 because this line is called x equals 6. We can also do a similar thing for a line that goes horizontally. In this instance, on this line, y equals 5. Let's check. 1, 2, 3, 4, 5. Yes, y does equal 5. Let's plot this coordinate in the correct format. Well, 1, 2, 3, 4, 5 is the y coordinate. Let's see what the x coordinate is for this one. 1, 2, 3, negative 3. All right, but it wouldn't matter which pink cross anywhere along this line here that I plotted, y would always equal 5. But not all lines run perfectly horizontally or perfectly vertical, and that's where we get into these linear equations. Remember, we're talking equations at the moment, not inequalities. Now, there's a special format that linear equations must be written in before you can draw the line, and it is this: y equals mx plus c. Now, we use specific pronumerals or letters when we're talking about linear equations. Obviously, the x and y mean something, don't they? Let's just highlight those. And if you had to guess what the x and y represent, I would pull you back to this graph here and say, well, it must have something to do with the x and y axes, and you would be correct. Now, the other two important parts of this format is the m, and I'll use a different color, and the c. Okay, now the m is a gradient or a slope, and more importantly, it's always written as a fraction. Okay, and I'll show you how to do that shortly. The c is what we call the y-intercept, which means where the line crosses over or intercepts y. Okay, So you can see one of these lines here does cross the y-axis. It's this one here. And one of them doesn't. So there is no y-intercept in x equals 6. There's no y in here. But there is a y here, and it equals 5, and there it is. Right. So we can use the information, or this background information, if you will, when we're graphing our equation. Let's do a simple one. Let's do y equals 2x plus 1. Now, the first thing I would ask you to do is check that it's in the correct format. Is it? Does it look like y equals something x plus something? Y equals 2x plus 1? Yes, it does. It's in the perfect format for graphing. We don't have to rearrange this equation and get x on this side and move stuff around. I'm giving you a nice, simple, easy one to begin with. All right, the second thing we need to do is write the gradient as a fraction. So if you circle the gradient and go over here, writing 2 as a fraction is simply 2 over 1, okay? 2 over 1 has the same value as 2. 2 divided by 1 is 2. Perfect. We've got it sorted. The next thing I need you to know is that, I'll just rewrite that over here, 2 over 1, when it's written like this, is a set of instructions about how sloped your line is. All right, if we're going to put it on a big one like this, will it go this way? Will it go this way? Will it be a very slight slope, or will it be a very steep slope? We don't yet know. But this is a set of instructions telling us how steep or which direction it's going to go in, because we can go uphill or we can go downhill. We don't know yet. All right. The 2 is actually representing a change in direction on the y-axis, and the bottom one is change in direction on the x-axis. So the first number, the number 2, is going to tell you whether to go up on the y or down on the y, and the number on the bottom of the fraction is going to tell you whether you're going to go in the negative direction or in the positive direction, okay? This also is negative and positive, as you would know on this graph. If we go up, it's in the positive numbers. If we go down, it'll be in the negative numbers. So the gradient 2, or 2 over 1, is going to tell us to go up 2 and across 2. Now, we know that it's going to be both in the positive direction because these numbers are actually positive, okay? If this number here was a negative 2, we would be going down. Perfect. Now, you'd be saying, well, that's all well and good, but where do I start this up, down, left, right business from? Well, thankfully, we have a y-intercept, so we know that we can plot this coordinate. Okay, if this is the y-intercept, x will equal 0. So we've got 0, 1 is where we're going to start that. And let me show you how that looks. If we were to draw on our steps here, I'm not going to do too many, do 3 or 4. Let's do the x-intercept while we're at it. Sorry, the x-axis while we're at it. And it's always a good habit to label your axes, x and y. All right, so let's work out, where does 1 on the y-axis sit, or where is this line going to cross over y? It's going to cross over y at the positive 1. Here it is here, positive 1. So I'm going to draw a dot there. Okay, and you'll see that x equals 0 there, just like we wrote over here. Okay, so this is our starting point. So we've got our starting point, we've got our set of instructions. So let's go. We're going to go up to, and I can circle that because it's positive, and I can circle that. We're going to go right. So we're going to go up to, across in the positive direction, 1, up 2 across 1, up 2 across 1. I like to chant that a little bit before I start doing my dots. Up 2 across 1, up 2 across 1, up 2 across 1, up 2 across 1, and you can keep going for as long as your graph goes. Now the next thing you would do is notice that these are all in a lovely line, so you're going to get your ruler out. I generally prefer blue pen because I like you to draw your axes in red if you don't have a photocopy, and it's very important to line it up, and then I want you to draw all the way across your graph. And you're going to put arrows on that because that tells the person reading your graph that this line goes on forever, which it does. It's not a line segment, it's an actual line, and lines go on to infinity. And the other important thing to do is label this line y equals 2x plus 1. Okay, so there's lots of methods for graphing a line. This is just one of the more simple ways of doing it. So I hope this revision has helped you. You should have done these in lower grades, just a little bit of a refresher. The next video we're going to look at, we're going to be graphing a very similar line, except it's not going to be an equation. It's going to be an inequality.